welkom bij dit webinar, deze Technical Camping op 8 november van dit jaar. We gaan zo meteen wat meer in de diepte duiken met Renard als het gaat om Technical Camping, WAF Fine Tuning en health checks. Voor dat moment, ik weet niet, hebben we wat huisregels. Next slide, Renard, please. Mocht je het niet kunnen horen, er zijn natuurlijk een aantal remedies daarvoor die u kunt doen met de audio of andere verbindingen te maken met uw telefoon. Als u vragen hebt, schroom niet, stel ze in de chat. Het zit ook aan de rechterkant van het scherm. U kunt uiteraard ook meteen, ik zal mijn gegevens ook achterlaten en die van daar ook mailen achteraf. En dan gaan we ze dan zeker op die manier ook beantwoorden. En we gaan deze sessie opnemen, dus u kunt het later rustig terugluisteren en op uw gemakje eventjes nog door de dingen heen die wij gaan vertellen, die we hebben verteld tegen de tijd. Next slide, please. Mijn naam is Maarten Labadie, ik ben partner account manager bij Progress, zo'n 3 jaar nu werkzaam voor Kemp Progress en verantwoordelijk voor het portfolio Kemp LoadMaster en Vlogen in de Benelux. Ik werk samen met partners en distributeurs om de beste oplossingen te bieden naar de markt op het vlak van LoadMaster, Load Balancers en Flow Network Monitoring Solutions. We hebben een exclusieve ervaring, moet ik zeggen, in de IT. We hebben onder andere gewerkt voor Getronics, de data en eigenlijk ook meerdere contracting, interim freelance rollen als consultant, business development en channel development. Next slide, please. Wij organiseren deze camping sessies eigenlijk, en ik vind, moet zeggen, de woordspeling, moet ik zelf al een beetje lachen toen we dat uiteindelijk hadden bedacht. Ongeveer twee maanden, om de 2 maanden uit de thema's de vragen die we krijgen uit de markt, partners en endgebruikers. Welke thema's eigenlijk hot zijn, welke zaken er zeg maar, wat behoefte is aan kennis die we kunnen overdragen in dit soort korte sessies, waarbij we eventjes wat meer hands-on de diepte ingaan op een aantal onderwerpen. En vandaag is dat health checks en WAF Fine Tuning. We hebben van volgend jaar over een aantal sessies, in ieder geval de ideeën, de data komen nog per mail naar u toe. Op het moment dat we zover zijn, dat zal waarschijnlijk eind december, begin januari zijn. En dan gaan we volgend jaar weer plannen. Die is wel erg leuk om te doen. En we merken dat er ook veel, dat onze partnersgebruikers daar veel baat bij hebben. Het is iets wat ook een beetje dingen losmaakt op andere vlakken. Dus nogmaals, als er achteraf na deze sessie vragen zijn, dan hoor ik het heel erg graag. De agenda, next slide please. De agenda is toch eventjes eerst de WAF Fine Tuning te doen, de health checks doen we daarna. En dan gaan we ook een beetje in de vorm van een demo daardoorheen. Dus het is niet alleen maar de droge slides. We gaan ook eventjes echt wat hands-on dingen doen. Renard laat wat zaken zien over hoe dat eruit ziet in de praktijk. En op basis daarvan hopelijk u wat meer kennis geven, wat meer inzet geven. En misschien wat dingen losmaken weer met andere vragen die u hebt in uw eigen omgeving, die daar spelen. Niet onbelangrijk om eventjes te weten is, de WAF-functionaliteit zit eigenlijk inbegrepen bij de Enterprise Plus subscription op het load balancer. Dus hebt u nu dat. De kans daarvan is natuurlijk heel groot, want anders komt u misschien niet in deze sessie zitten. Maar overweegt u de functionaliteit te gaan gebruiken, dan moet u eigenlijk ook even kijken naar die support subscriptie optie. We bieden een aantal mooie paden van standaard of Enterprise naar Enterprise Plus toe, waarbij u nog gebruik kunt gaan maken van die WAF-functionaliteit. Met dat gezegd hebbende wil ik graag het woord geven aan Renard. Renard, the floor is yours to elaborate us on WAF Fine Tuning and health checks.
Thank you. Will you have a look at the questions? If they come in Dutch,
Absolutely.
I won't be able to read them, right? So, great. Cool. Yeah, welcome also from my end. Sorry, my Dutch is not existent. I'm not from your region. I'm from the DACH region, and because I don't believe you speak German, let's keep it in English for now. So my name is Renard. I'm the pre-sales engineer for DACH and Benelux. So all question regarding the load balancer you can come to me with that. This was me before COVID. Let me turn on the webcam, then you see me now after COVID. So now I'm looking like a Viking a little bit. So hi, and home office makes it possible. So yes, I'm with Kemp, or now Kemp Progress, for over 6 years. I was in the Kemp support, and now for the last 3 years, I'm in the role of the pre-sales consultant. So yeah, anything you have there, professional services, questions, POCs, anything that you need to know to be able to sell the load balancer or to use it, let me know and I'm happy to help. Great. So today's topics: WAF fine tuning and health checks. So let's start with the WAF part. I did do the webinar in German before a couple of weeks ago, so hopefully it will be a success today as well in English. So maybe let's talk first about WAF anyway. What is the WAF in the first place? So WAF is short for Web Application Firewall. It is to protect your application against the top 10 OWS vulnerabilities, also to protect against data loss, and yeah, to have a real-time protection in front of your application, right? So what will happen? The load balancer will inspect the inbound traffic, and if you want to, also the outbound traffic to make sure that you might that you detect maybe already an infected server on your end. So we can detect both, and you get daily rule updates. I will tell you more about those daily rule updates also. But the fact, first of all, is it can inspect both. Now, last year we changed our WAF. We had now, if you have a load balancer, you will see that there's a legacy WAF option and a normal WAF option. So what was the difference to those things? So the legacy WAF was built on the rule set from modsecurity.org and commercial rules from Trustwave. You might have heard that Trustwave is not working with mod security anymore. And they made specifically app-specific rules. But for example, if I remember the Hafnium thing with Exchange, they created a rule for that. It took weeks before that happened, but they created one. But then they didn't put it into the folder for Exchange or for OWA. They put it in the general folder, which no one has used. So the syncing of that was just not good. So we turned away from them, and we developed the new WAF, which is using the core rule set right now. It's similar to the core rule set that all the cloud providers use, and has a very high detection rate and very high security rate. And as you see here already, the new WAF definitely has loads of more yeses than the old one had. The only thing we don't do is application-specific rules. And why would you? If you have generic rules anyway, why would you have an application-specific rule? Because then you probably trigger 2 rules at the same time, so that makes no sense. Now, so that's for the difference between the old WAF and the new WAF. In the next version, I think 59, the legacy WAF option will disappear, just to give you a heads up. Now in 58, it's still there, but in the next release, the legacy WAF will disappear. Is a web application firewall enough? Do you to protect your environment? Do you need anything else? So I can say it's not enough. You still need your normal perimeter firewall, right? That is protecting you on the network layer. A web application firewall is simply to extend and upgrade your normal perimeter firewall, because it will look into the web application traffic. So everything that's HTTP, HTTPS, the web application firewall will look into that. A normal firewall won't, because it doesn't break open SSL. It cannot look into the traffic. It cannot detect if there's an SQL injection or not, but a web application firewall can. So you can see it as an extension of your normal firewall to protect your backend servers. Great. Now, that was a little bit recap on what is WAF in general, and how is the difference between the old and the new one. Now, you might have heard about paranoia level. So the new WAF allows you to work with different paranoia level. There are four of them. So you can say, okay, the paranoia level 1 is less aggressive. You don't have that many false positives, and the higher your paranoia level goes, the more aggressive rules will be added. But that also means your false positives could be extended, right? Now, normally we start on paranoia level 1. And there is in the core rule set, I think about 250, 260 rules in paranoia level 1, and paranoia level 2 will add another 30, and paranoia level 3, I think it's another 15, and 4 is another 10 or something like that. So this more or less, don't nail me down on the numbers, but that's the direction. So what paranoia level do you need to choose? That depends on your application you try to publish. If your application in the backend does not include any personal data information, then you're totally fine in paranoia level 1 because you are considered the risk class 0. In risk class 1, that means you have personal data involved. There's names, there's addresses, there's stuff that someone could steal from your page. That's risk class 1. Then you should work to get your WAF to paranoia level 2 at one stage. Not starting there, you start always on 1, but you build yourself up. Risk class 2 means you have sensitive data. So for example, you are a bank, or you have information like on that level on your application, then you should look into paranoia level 3. And risk class 3 is super sensitive, so you run an atomic reactor, and you do not want this to go down at all. So then you should look into paranoia level 4, right? So to have a simple web page without personal data, there's no need for you to look into 3 and 4. No way, you don't need to go that far, right? So you only need to do 1, maybe 2 if you feel like it, but you don't need to go higher. So this is simply to explain the paranoia levels that you have. There's also another thing that you can select on our WAF. It's called execution paranoia level. So how does that work now? What is the difference? Blocking level means this is the level I'm running my rules, and I count all the points together, and if I reach the threshold of the scores, then I will block. Executing level means it's for fine-tuning. I can look into another level, for example 2, can review what the rules will be triggered, but they do not count to the threshold score, so they don't cause a block. You can see that they get triggered, you can react on that, you can fine-tune, but they will not cause a block. So why is that separated? Why is the blocking level and the execution level different from another? Very, very simple. You have 2 approaches on getting your application secure. You can either do it in a soft manner or in a hardcore manner. The soft manner means, okay, I start at level 1, I start with a high score, so my normal production can continue on. No one will notice that I have increased the security, that I'm recording what kind of rules are triggered, that I'm doing fine-tuning in the backend and slowly getting more secure with every session that I'm doing. Because there's no downtime, there's no, your application will never stop working. So that's a soft approach. You do multiple rounds of fine-tuning, and at one stage you have your threshold down to 2 or 3. That means if one rule gets triggered, there will be a block, right? You have everything fine-tuned, there's no false positives anymore, happy days. And then you would be ready to go to blocking level 2, right? You can go to paranoia level 2, but you don't want to reduce your threshold score anymore. So what you do here on the load balancer is, after you have done all your fine tuning on level 1, you can set the execution level to level 2. So you see all the rules of level 2 when they get triggered, but they don't cause any outage. You can fine tune. And then when the fine tuning is done, you can simply change your blocking level to paranoia level 2. And no one will notice that you have increased your security again and it didn't got any outfall. So that's a soft approach. The hardcore approach would be, I'm not fine-tuning anything. I set the score down to 1 or 2. And then I'm waiting for customers to call or users to call at the help desk and saying, yeah, my request doesn't go through, and you do it that way. But that definitely causes outages. That's why hardcore, right? So I would not recommend that option, but everyone need to make the decision themselves. But here anyway, you have the option to do a soft approach to make sure your application is running at all times and doesn't get disturbed. So yeah, I've shown this here, hopefully with a color. So blocking level is 1, meaning the score is counted. For blocking decisions, it's used. You have each rule can have a different score ranging from 2 to 5. So critical rules have 5 points and notice only 2. And if one request triggers multiple rules, then the scores get counted together. And as soon as you reach your threshold score, then the block is created. So the lower the threshold, the less rules need to be triggered to block. And the execution level means they are executed, but the score doesn't count, as I already said. And right now, as you see here now in green, paranoia level 3 and 4, we are don't even looking into those, because you should only look into one level at a time. You should not look in all levels straight away. So that's for blocking paranoia level and execution paranoia level. I will show in the demo in a minute where to find this. Now, you might have wondered already, if you looked at the rules, you wondered already, okay, where do those rule ID namespaces come from? So what is the story behind that? So I put the link where I found this information on. So the core rule set that you have available on the load balancer is ranging from 900,000 to 999,999. So these are the IDs of the core rule set. And then there is a range pre-declared from 10,000 to 99,999. This is for rules that you can write yourself that should trigger before the core rule set. And then the range 50,000 to one below 80,000, that is for after the core rule set. So that's what mod security has designed that way. And if there are rules that should be shared between different companies, then the range should be 80,000 to 1 below 100,000. And now you can see there are multiple companies that have reserved certain ranges, like Komodo or Akami. There also is a range reserved from us, from Kemp, because we had the idea that at one stage we might write rules ourselves, but that's in the future. But there's a certain range that we have reserved for our own rules. Okay, so I would recommend when you create a rule, if it should trigger before the core rule set, use something below 50K. And if it should trigger after the core rule set, use 50 to 80K. And then you're on the safe side. Right, so this is now about the ID. So what should a rule look like? How can I write a rule? So what would that look like? How can I do that? So the rule writing rules, say it that way, they're actually quite simple. So the mod security engine kind of predictates the format of the rule. So first of all, you have a directive. It could be sec rule or sec action. That's a directive. And depending on the directive you have used, there could be different parameters to set, right? So for the sec rule, for example, you have a variable. So what should I look into? Like, for example, the request URI. Then you have an operator in quotation marks. I try to color code it a little bit. Hopefully it worked. So the operator is, what do I need to match? So for example, here, I want index PHP to be matched, right? As a regular expression. And Then you might have transformations. Transformations are things like I want everything transformed into lowercase, or I want it normalized into from Linux format to Windows format, or the other way around, stuff like that. And then you have the actions. So there could be one action, there could be multiple actions. So an action would be, okay, what's the rule ID? What's the phase of the communication? I will explain that in a second. What should happen? Should it get a deny? Should it get an allow? Should it get a block? Or should some other rule be triggered? Those kind of things. So these are the actions. So you can, the transformations and the actions, they can be mixed like I did it here. You could have multiple transformations, you could have multiple actions. So this is the format for now. Just to give you some examples, there are way more, but just to give you some more examples. So this are the 4 parameters we just spoke about. So variables, there are, as you can see, 6 different categories. In total, there is around 105 variables to choose from. Operators, you have 4 different categories and about 36 different operators. So begins with, contains, regex, stuff like that, right? Equals, greater than, lower than, stuff like that. Different schematas, so there's loads of options for operation. Transformations are also 6 different categories. I only put 4 here, but there are 6 categories and about 35 transformations. And actions, you have also 6 actions, or 6 categories of actions and 47 actions that you can use. So block, drop, deny, chain, meaning you can add multiple rules together, skip, you can lock, no lock, yeah. So as you can see, pause, there's loads of different actions you can choose from. So that's for the language anyway. Now let's come to, as I said already here, I said the phase. So let's explain that. I took a picture that Christian Follini, who was one of the main guys in the mod security section, that he wrote himself. So I went to a training a couple of weeks ago, and this was a picture he drew himself. So as an example, this is a web page using Apache. So how does the phase thing work? So your client is communicating and trying to get something from your web page, right? So the communication starts. There's the SSL handshake. And so then as soon as the request line hits the mod security engine, that's when phase 1 starts. So the SSL handshake has been finished, and now the request headers are received. So this is phase 1, right? So right at the beginning. Then as soon as the body request has been received, phase 2 is starting. And then phase 3 is more or less the application time. So the request has been sent to the server and is now the answer is coming back. So this is where phase 3 is then ending as soon as the answer is hitting the engine again. And then phase 4, the response body has been received, and now everything is ready to be, the answer is ready to be sent to the client again. And phase 5, meaning the answer has already been delivered to the client. We are now just doing some logging and cleanup and stuff like that. So this is where the 5 phases come, right? So phase 1, request header is arrived. Phase 2 ends where the request body has been received. Phase 3 is as soon as the answer is coming back from the server. Phase 4 is then sending it all, when the body is there, sending it all back to the client, and phase 5 is the cleanup. So these are the 5 phases you can put your rules in. Great. Now, when I want to have some rule exclusions, or when I want to do fine tuning, there's multiple ways of interfering with the existing core rule set. So you can have rule set in the startup time, so before the rule is triggered, or you have rules, or you interfere with rules when you have in the runtime part. So, for example, you want to disable an entire rule. You can say that, yep, I want to remove a certain rule by ID or by tag. For example, I have a client that is allowed to do, certain requests. And I can then at the startup time already say when that client comes in, a certain rule is disabled. That's startup time, an entire rule. You can also say at the beginning, okay, for that certain application, we change a target for a rule. So we only modify parameters in that rule. We don't disable the rule, we just change parameters on the rule. So that's the target up there. And then you can also say, okay, during the runtime, I now remove a rule because of a certain situation that occurred, or here as well, I remove certain parameters that are triggered and that remove the rule. So these 4 options you have to modify rules. Now, I got you some examples for that. So the first rule, there is a core rule set rule called 920350. That's the rule ID. And that will simply say, okay, I'm triggering because the client has requested something with an IP address as a header instead of a host name. So if you want to disable that rule, then you need to create a rule, tell him what phase it should run. So for me now, if the remote address that comes in is my client, then the rule 920350 should be not triggered. So for this client, that rule is disabled. For everyone else, it's still there, but for this client, it's disabled. So that's what this rule is doing. Then there's other options. For example, this one is a sample here to cause a whitelist or blacklist for IP ranges. So if you are part of this IP range, then you should be allowed. If you're part of this IP range, you're allowed. And if you're part of this range also, and if you're part of anyone else, any other rule or any other range, then it should be denied. So only these 3 ranges are allowed. Everything else is denied by default. So that's what these rules do. So they're in a row, 3 of them in a row, and yeah. So that's also an option. And then the last one here is a content type header. So I had that for Active Sync actually, and for MAPI. So this is a rule that exists on 90.0.20.20. It's core rule set, and it has a certain list of content types that are allowed. And I now created a rule to override the parameters for the existing rule. So that's what this is doing. So it has, that's why you see no log and pass. It's an action rule. So you change the parameter for the normal rule there to allow the extra variables, content type variables also. So these are the few examples. And I also collected a few links for you to review and to get yourself more familiar with. And it's 10:30, halfway through, so it's time for a demo. Now, let me quickly get my domain controller back on. Oh, come on, sleepyhead. Cool. Martin, my machine can be seen, right?
Yes, it's perfectly viewable. Yeah.
Good. Okay. Now, this is a load balancer on 58 already. This is my test page that I try to access. So the service is this guy here. So this is my service now I'm using to show you the WAF part. What do I have enabled here? I have a WAF engine on, and as you can see, there's only core rule sets enabled, and my threshold is not default at 100. I have it reduced to 9 because I wanted to show you how this is triggering. Now, even if it's at 100 and you have not tuned anything, that still means you already have a protection, okay? I've seen in a university in Germany, we enabled the WAF, and a week or two later, they were under heavy attack during the weekend. There were people trying to hack their exchange system, and they triggered so many rules at the same time with their requests that we got way above the 100 points. So the load balancer did protect a lot, not everything, but a lot. So sure, we haven't fine-tuned it perfectly at that stage, but it already gave a big, how should I say that, a big shield against those attacks, right? So here for me, just to show you how the scoring works and how the triggering works, I have reduced it to 9, meaning if I trigger 2 rules with 5 points, I get an access denied. That's what I wanted to see, okay? So this is your blocking. This is the threshold score, so it's set to 9, and my blocking level is 1. So I'm only using level 1 rules right now. Here in advanced settings, I can, as you can see, I can increase the blocking level once I'm finished with my fine-tuning, and I can also increase the executing level, remembering that means I can review the rules on the next higher level without it counting to my threshold points, so I can do fine-tuning before I jump with my blocking level up. Okay, great. So let's move back. Okay, so this is a normal web page right now. As you can see, I'm accessing the page. I get my answer from the server back. So I'm at apps 1 right now. It's a simple request on root. There's already a content switching in here that I'm requesting an index PHP page. As you can see, this is my client, and I just do a normal host and a normal entry, so all fine. 1 second. So now let's trigger a rule. So let's be a bit naughty and say, okay, I want to do something nasty now. And I'm calling, for example, a path bin bash, right? So now you see I have a query item sent. I'm doing a bin bash request, and in my false positives, you see my rule has been, there's a rule that has been triggered. It's rule 92.21.60 that has now been triggered, and it cost me 5 points. So right now 5 points is lower than my 9 threshold, so I still get through, but the load balancer is recording, hey, there's the rule that has been triggered now. That's not okay. Now let's pimp it up a bit. I know we need to look at the time. I'm now using something bad, like for example, I'm using a user agent with of a bot, for example, zgrab, right? We do the request again. Oh, what happened? Access denied. So what's going on? Yes, I did a second request. I have the zgrab was found in my user agent. And now because of both rules were triggered in the same request, I counted a 10. And a 10 is higher than my threshold score, and now I got a block. All right, I hope that was clear so far. So this is how the threshold works. I got 2 rules triggered, getting over my threshold point. Now I get access denied. Okay, right. Now let's look into a rule to say I want to now fine tune my unit here. My client is allowed to do a bin bash command. So for him, let him create a sec rule. So if that client comes in, then he should the rule with a shell command should be disabled, should not be touched for this guy. So let's activate this rule. I have already imported that, and we can just enable this. Come on, here we go. Now the rule is enabled, and if I now do my request, I get passed again, and in my thresholds, you see now I only get the Z grab is counting up. The bin bash is not counting up anymore. So let's do this a few times. I'm refreshing this a few times, and you now see the count here goes up, but that rule is not triggered anymore because for my client, the rule was disabled. For any other client, it still works. It's still there, but for my client, it's disabled. Great. So now you've seen how the fine tuning can be done. How about we want to upload a WAF rule? So let me double check. Here we go. I have a deny rule created. So let's have a look. So the deny rule is this guy here. So that's a new rule having a regex if you come in with a user agent called WAF Fine Tuning, then that's not allowed. So then there should be a deny, and it will, as you can see, it will normalize to lowercase so that it's matching here. So it will normalize that. And you see here it's a critical rule, so 5 points. And also this is a few things in the logs that with the log data will be extended and so on. So let's import this rule, and I will show you what that does. So to import the rule, you simply go here on the left-hand side into the Web Application Firewall part, and then custom rules. You can choose the file and add the rule. So now it's installed, now it's available. And now I can go into my service where I want this rule, and I can choose it from the available custom rules. Happy days. And now let's change this to WAF. And I'm now using capital letters. As you see that you can see that the normalization works. So I have capital letters used, and you see with the one rule being triggered, I straight away get an access denied. And in my logs, you will see in here down here that the rule has been access denied, error code 403. That was the rule that was triggered there. It's not counting up here anymore because it has nothing to do with the counts. It's a rule that denies straight away, and that will be right there showing. Cool. So much about the WAF fine tuning session 1. There's way more to be done on the WAF, but it would just kill our time slot for today. So let's continue on. Health check options. So there are multiple options for health checks on the load balancer, right? So we have application-specific health checks, right? So layer 7 and also layer 4, even though there's only a small list of layer 4 checks. So layer 7 checks, application checks, they're more accurate than just the layer 3 ICMP ping or layer 4 TCP check, right? You can configure the health checks on a virtual service, or if you have sub VSs in each sub VS. The HTTP and HTTPS checks. They are very highly configurable. I will show that in a minute. And you also have various mail protocols. You see here FTP protocols, Telnet protocols, and so on. On UDP, we only have ICMP and DNS or LDAP for now, but who knows? That might change at one stage. So here are the different options that we have. Layer 3 ICMP, layer 4 TCP, and these are all layer 7 checks, and also the non-option. Now, there's also an enhanced option for on your virtual service or subservice for your application server. When you enable that, you can first of all set the minimum amount of application servers that should be there for the service to be running. But you can also say that a unit is that a specific server is critical. So if that one dies, the whole thing goes down. And you can also say he should not do the check on himself. Instead, he should use the answer from a different service as well. So that could reduce the amount of health checks you do. That also gives you the option with Nest services to do multiple health checks in one go. I don't have a webinar on Nest services yet in English. There's one in German on our YouTube channel. Maybe at one stage when you choose the topics, we do the English one here in the Benelux region. Now let's have a look into the HTTP checks. So if you choose HTTP or HTTPS, you can also choose what port should be checked if it's different to the port you add the server to. You can choose the directory that should be requested. If you want a different status code to be seen as good than a 300 code or a 200 code, then you need to add the number in here. It will override the default behavior and will accept the ones you have set in here. If your server is not okay with the IP address / the URL, and instead it wants the host name, you need to enable HTTP 1.1 and then add the host name in here. And then you can choose different methods, get, head, post, I think options is also there. You can choose different methods, and then you can even fine tune a reply pattern so that the web page that answers needs to have a certain content, and only then it is marked as healthy. And you have the option to even add other headers. For example, you can add an authentication header and send a username password coded over so that you have already an authentication as well during the health check to see that you get your right point. So this is a HTTPS or HTTP check. And you also have an option to do this in binary data. I don't know why they put that in, because to be quite honest, it's a nice gimmick, but if I look into this in half a year time, I would not have a clue what that actually does, because I'm not reading binary that well. So for example, here we are sending a request to the server. It's coded here, and I've just highlighted what I'm doing. So it's a GET request with /index.php and then a line break and so on. So this is what we send up here, and then this number is what we expect back, the reply pattern, right? And if you can see, my reply pattern is app1 test page. That's what I want back. And only if that arrives back, then the server is marked healthy. And if that doesn't reply back, then it's unhealthy. So binary data is an option, but it's not, it's not that simple. But there is an alternative option. If you look, if the real server health checks are if you broaden your mind on that a bit, there's also an option using adaptive scheduling. So it's actually not a health check per se, but it can be used as one. So what does that do? I always considered this to be Stone Age technology, but it's actually not. So you have a script on your server. The script is run in a certain periodic time, whenever you can set that yourself. And it will check for certain resources. For example, what is the status of my hard drive? What is the status of my RAM, of my CPU? Is my web page available? Is my other application available? Stuff like that. And based on the outcome of all of this, it's generating points. Okay. And what you need to do then is you enable a web page on that server to allow for this value to be returned. And the load balancer is calling on the server for that value. And based on the value, it will make a decision. If I send traffic there, how much traffic do I send there, and so on. So that means for the scheduling parameter, you can also include health check options in there, or status options if your application is running. So if the load balancer receives no response, a 101 or something bigger than 102, then it will put the weight to 0 and not send any traffic to the server anymore. If the file doesn't exist or is empty or has a value below 0, then it will be just presumed to be completely healthy and gets normal scheduling part. If it's 0, it will the schedule method will be changed to round robin. A value between 1 and 100 means I can set a weight. So for example, if the value is 50 and for the second server it's 100, then you know, okay, my second server can take double the amount of the one that returned 50. And if it's 102, it's a specific one. The weight is set to 0, so it's not accepting any new traffic, but it's not keeping the old one alive. It will drop all old connections as well. So it will, kind of get disabled in that moment. And this is something I wanted to show you because I believe this can also be used for a health check option. So I also have a few links for you, and I'd like to use the last 11 minutes to show you this in the live demo, and I hope we get this done. There are no questions so far, I see. Feel free to ask questions. I'm not biting, guys. So here is my load balancer. So let's have a look. As you can see here, I use a binary data check. I'm sending the GET request and I'm expecting back app1 test page. And what's the result? My app1 server is available. The app2 server is not available, right? Because you might remember, let me change this to default here. You see my server is responding, or the pages that is giving back is using the host name of the server that is the page is on, and then just adds this part. So if I'm looking for app1 test page, my app2 server, of course, can't fulfill that. Now, here in my second example, I didn't use binary. I used the normal HTTP check. You see, I'm checking on index with a GET. And here I request now app2. So the app1 is down and app2 is there. So let's just open this guy. There you see, app2 is the answer. And if I would change that to only say I want test page back, I don't care what server it is, then my app1 should come alive. There we go. Now it's there. Meaning if I request this a few times, I should definitely get a round robin to app1 as well at one stage. Okay. But I have resource based here, so that makes things a bit different. Okay. But that's on the health check. So as you can see, there's loads of options. I could also send the name of the server with it. I can choose between head, get, post, and option. I have the reply pattern. I can add a header. And as you can see down here, I can say I need at least 2 up or 1 there. I want critical, or I can choose any other answer of any other service on this load balancer to be used. So he should not do a check himself. He should use an answer that's already there to reduce the amount of health checks being done. Cool. So that's web-based health checks for now. Let's get to the other option. I choose here the scheduling method resource-based. Okay. As soon as you do this, there's a new option here on the rules check parameters. You see this here. It's called adaptive parameter. I've set it to the lowest, which is 10 seconds. So every 10 seconds, it will go to the server and check on /load99. That was my folder that I use for that. And I set a certain port for this. So 8090 is my port. So every 10 seconds, the load balancer will load a file from my server on this URL on that port and trying to get a value on how much the server can take the load. You can see the values in statistics, real-time statistics, and then on your real server. So here you see my app 1 is returning 28. Second, I get bombarded. That's so great. I'm in a meeting, I'm red, and I get bombarded with people on Teams. This is a nightmare. So coming back, sorry. So you see my app 1 is returning a 28 and my app 2 is returning a 73. So normal weights, they're both healthy and they can take traffic on, right? 28 is way, way lower than 73. So it's no surprise that I always got app 2 here. Now you see now it changed to app 1, but the load was much less on app 1. So great. So the load balancer is refreshing this all the time, and depending on the value, it will now send traffic to those servers. What happens if I change the value? You see here's the files where the values are in. Now, if I change a value, let's, for example, say it's a 102 now. And just to show you how this I just manually override it, but this is the script. If I would run the script, it would change my value based on the parameters. So as you can see, you can download this on our webpage, by the way. So it will load my folder and publish that. And here I'm checking, for example, the free memory and the total memory. It's calling for my web pages, if they're available or not. It's got a certain status on that. And you can also include CPU load. You see I've disabled that here, but it's already there. You can calculate hard drive space and all of that. And based on all of these values, then a number will be returned, right? That's how that works. So if I run this, there you go. So I got a new value called 34 for this. This is my app 1. So app 1 should be now 34. And app 2 value, oh, I haven't changed that. So let's change app 2 to 102. I don't run the script there now. I just manually change this file. And now on the load balancer,
we have 5 minutes to go, Renard.
I know, thank you.
Thanks.
You see my value for app 1 has been changed to 34. That was running after the script. And now the value for app 2 should change now in a few seconds as well. And there you go, 102. You see it has changed. And the result of that means I'm still taking load on app 1, but because of the 102, my server 2 is disabled now, not taking any more traffic on, not serving any old persistent traffic anymore, because he's now out of service until the value changes back to a normal proper value. So let's just pretend. Let's do 25. So we change, You see this is on my app too. We change the value again. And as soon as that happens, it will become green here again. So it's a normal automatic thing. And now it has done that. And you see app 2 is there again. So that's why I think the adaptive scheduling method also can be used as a health check. And I even believe I had customers using SQL databases, and they wanted to have an active and a passive one. But there's no web page to say I'm active or passive, and it should automatically switch. So I think the adaptive balancing for those use cases is the best, because based on if you are active or passive, it could bring a proper status back. And for example, if you're passive, it should do a 102. So that will be disabled on the load balancer. And as soon as the database swaps from A to B, the status changes, the value changes, the load balancer would then automatically enable that server. So as a user, you don't have to do anything, and you have a proper switch over. So that's why I think health check based on scheduling method can also be done very wisely and has a proper use case for that. And that means I showed you how that works. I made a health check fail. I showed you the health check options. That means I'm done. Thank you so much for your attention today. And I hope you join me for the next webinar session. And I hope you liked it. Please send feedback on things that I can improve. Let us know and vote for the next topics. I'm excited to see what you're interested in. Great.
Thank you very much, Renard. En dank u wel voor uw komst, voor de tijd, voor de aandacht. Mochten er vragen zijn, uiteraard kun je ze natuurlijk per e-mail naar ons versturen, naar mij of naar Renard. Nog eventjes als laatste uitsmijter. Ik had al even aan het begin aangegeven, WAF is onderdeel van de Enterprise Plus subscriptie. Dus mocht dat nog niet aanwezig zijn bij u, mocht er interesse voor zijn, stuur me ook uiteraard een mail. Dan kunnen we daar verder over praten. En voor volgend jaar, als u onderwerpen hebt, ideeën over wat wij deze soort sessies moeten behandelen in de diepte, dan geef het ook door. Dan gaan we daar mee aan de slag. Het is jullie input, jullie vraag die het daar ons instuurt. Dat gezegd hebbende, nogmaals dank voor aandacht en voor de tijd. En tot de volgende keer. Een fijne dag.